Hello everyone. Today I will be playing and reviewing a game called Hard Chip. This is a game based on circuit design and building computers from the ground up with transistors and wires. Now the creator reached out to me several months ago and I did give it a try, but it's been such a long time since then and I want to give it another shot, especially since it has had some updates since then. When I played it before, I found it very interesting and I had only gotten in about 30 minutes, so I'm interested to give it a shot. First, can we appreciate just how awesome this music is? Now, the creator probably reached out to me because of one of my previous videos about the game called Turing Complete. In this game, I had built an entire y86-64 processor using just the wires and components built into the game, and it was able to run real binary files that would have run on a y86-64 processor. Now, I don't know if I have time to do that today, but I'm definitely looking forward to playing this game. So since I have some progress, I'm just going to go in here and reset my campaign. Alright, and then let's hit new game here and give it a shot. Alright, it looks like we have some kind of corrupted data on this device. Oh, that's a bit creepy. Looks like I am alive now. Press any key to acknowledge. Okay, so this room is pretty dark. It's hard to see, but I can move around. And there's this console over here. Looks like I can press E to interact. Let's see, we've got some error codes. General failure, unspecified error, IO error, power surge, hello. Critical failure, system reboot required. Alright, I'm going to just type reboot. Attempting forced reboot. Looks like it's going through and things are okay so far. Generator status offline. Engaging startup. Establishing connection failed. Okay. So, it seems like we're inside some station. Things are not going well. Generator status is now operational though after a reboot. That's the first rule of tech support. Network timeout, connection lost, power surge, safety door failed. Trust in the guidance I offer, for my only aim is to lead you to clarity and resolution. Let's see what I've got here. Status. Let's check the status. Okay. Bypass chip damaged. Immediate action required. Replace the bypass chip. Requirements sent to workstation. Okay. Is this my workstation? Yes, it is. It's got the workstation handle right there. Received requirements for bypass chip. Ready to start design process. What can I do here? Now, I think resetting the campaign didn't actually end up resetting these things, and that was intentional. But I'm just going to go back into the first level here just to show you kind of how the game works. So by default, you can move around with right click here. Press and hold right click to move around. Zoom in, zoom out. So it's basically a grid system where you can place these traces, which are just like in real life kind of metal wires that get built into PCBs. And I had placed these down in the previous version, or before I reset the campaign, I had placed these down. So we can validate that the red signal goes through and the blue signal goes through. So this is kind of just your tutorial levels, and we'll go through them quite quickly. Yes, so there's 1 for red, 0 for blue, and then gray being neutral. You can turn on and off traces, or you can turn on and off inputs rather. Let's see, click me. And now I click again and it becomes a 1. Perfect. And then we'll validate the circuit, and that's all very good. Now, let me reset this one. Okay, it's just going through, yeah. Okay, let me restart this level. So this is how it starts out, and this just is showing you that if you turn on two inputs with differing signals and they're connected to the same trace, then you'll get this yellow tile here, which shows kind of an indeterminate state. It's kind of a noisy signal if you're to give it that analog. So let's validate the circuit, and as we can see, it doesn't work. So I'm going to hit Alt and click to isolate that trace, and we can now validate. Perfect. Moving on. Compliance. Some validation requires multiple steps. Each step has its own requirement, and they are listed here. This is similar to Turing Complete, where it shows you your inputs and outputs. This here is showing you that the test will put in a 1 and a 0, and it's expecting a 1 and a 0 out. This is just input output without any logic really. Okay, let's delete that and validate. Perfect. Went through all the tests. And that's how we'll start working on digital logic. Okay. Now this is what makes it unique with regards to Turing Complete. Now, I'm having trouble remembering how to rotate, which is going to be important for this because obviously it's 3D. So this is just showing you that each trace to be isolated from each other need to have at least one cubic unit apart, which makes intuitive sense, of course. So to isolate traces from each other, they must have at least one empty space. Following the criteria, input A must be connected to output A, C to output C, and B to output B. Add traces by pressing Shift and then dragging the mouse up. Separate traces A, B, and C, and then validate. As you can see, I had already done that before resetting my campaign, so I'm just going to keep that. Okay, looks like I didn't. So first I will just do that kind of naively, and then here I'm going to bring B. There we go. Oh, okay, when I want to move to the right, then I don't hit Shift. I see. Okay, that actually makes a lot of sense. So Shift is to go up, because obviously, how are you going to move your mouse in the upward direction? I see. Okay. Alright. That was just me then. So, alright. Let's go up, 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 up. So that should be enough to clear us of the B trace, and now we're there. So we can go, let's just go straight down. Okay, this is so much easier now that I read that. Perfect. Amazing. Alright, so that, okay, looks like there's a bonus one. We want to go across the wall. Okay, this is one that it looks like I did do. Alright, there we go. Alright, so now we have a unlock next section, fabricating this chip, sending design to fabricator. Done. Oh, okay, where's my fabricator? Fabricator. Alright, let's see. Material banks unavailable. Buffered materials available for limited operations only. Boot sequence complete. Ready to start. Okay, so let's see what... Oh, okay. Hey, it gave me the commands anyway. Alright, let's do fabricate. Bypass chip ready. Fabrication log saved. Error code look up. Okay. I'm looking at... Oh, there it is. Now I have the bypass chip. Okay, so what am I going to do with this bypass chip? I'm going to go over here. Okay. Unspecified error. Bypass chip replace boot required. All right, reboot. Opening safety door. Whoops. Alright. Whoa. This is big. Okay. What do we have here? This is... Okay, there's some kind of arithmetic error there. We're not ready for that yet. And this is also disabled. So let's start here. Network timeout, connection lost, power surge, damage likely, arithmetic operation error, general failure. All right, let's check the status. 8-bit ALU chip damaged. Okay, if I'm going to have to make an ALU, this is going to test my memory of my computer design course. Alright, workstation not ready, material banks offline, bring material banks back online to continue. So I think that's back over here. Where's this? Okay, this is material bank 1. Alright, status. Inverter chip damaged. Alright, so here's where we actually get into some basic logic. Okay, replace the inverter chip, requirements sent to workstation. Here's my workstation. Alright, start, I think. There we go. No chip found in the database. Alright. Okay, it looks like I did get here in the game, though I don't remember that. So I'm gonna just, let's see. Oh, I should probably read this. MOS has two major parts, the gate and the channel. This one, MOS, is a PMOS, positive MOS. It acts like a switch that can be either activated or deactivated. Applying 0 to the gate, this reddish thing here, activates it, allowing only 1 going through it. Applying 1 deactivates it, blocking all state going through it. Look for the help here or try wiring the PMOS by yourself. Entering this will, entering 1 on here allows, yes, if it's 0, it allows the signal through. However, if it's 1, then it doesn't allow it through. Looks like it will also not allow any zeros through, so we're going to validate it there. And that works properly. Now we're going to do alter ego and MOS. So this is the negative version where you send it in a 0 and it will allow or not allow a signal through. So that's a little annoying. I didn't mean to put a block there. See, now I don't know how to get out of edit mode. Maybe right click. Anyway, you send in a 0 through and then a 1, and it lets that through. And it won't let through a 1. However, when it's 0, it won't allow anything through. Perfect. It looks like the color of these different check marks show whether it's made most efficiently. So for example, in this one, I think I used a couple extra traces that I didn't need to. So let's see, the merger. This one, a special shape MOS can have 2 gates and share the same channel, create a merged PMOS with 2 gates, and then validate. I'm not sure if this is something I already completed. It probably is, since it worked. Alright, so now we can unlock the next section. Okay, here we go. Well, let's make a NOT gate. Most of the time, a schematic is available with this new chip icon. It provides optional steps to build the chip for each level. Use the schematic or not to build an inverter, and then validate. Okay, so using it looks like we have available the two different things that we made before. So using that, I'm gonna need to build an inverter. So let's think about this. If let's reset the level. Alright. Alright, so we wanna get our positive and our negative. Looks like we want to join their gates into one, so let's do that. The 1 will, looks like, always go through the PMOS. Did that? Yes, okay, that did link up. So let's go up one. And then the 0 will always go through the negative PMOS. And then the input, where does the input go? The input goes to their gates. And then the output just simply goes out. Let's validate that. I see. Now, looks like the next step is to compact this. The die size was fixed until now. Now the size will be dynamic. If you need more, okay. See, I didn't mean to place that. That's very annoying. I wish I hadn't placed that now. And then finally, connect those up. Then this output can all be joined to that one, and we're done. What? Oh. I see. Alright. What do we have to do here? Use the compacting the... Oh, this is just showing me that I can use blueprints. So, blueprints. There we go. Compacting the inverter. Ah, there it went. It saved the weird line at the end that I didn't mean to. Validate. Alright, I guess that's fine. Unlock, and it looks like we're ready to fabricate the chip. Fabricate. So for sake of time in the video, I'm just going to skip ahead to making the different circuits and not show any of the lab stuff, but that stuff is still there. So we're making a NAND chip, so looks like what I have here is just the PMOS and the NMOS. So, let's validate. We get our 1. We don't get a 1. Don't get a 1. And don't get a 1. Okay, I want a schematic. Okay, that is way more than I thought. Right, and then down. Validate. Please work. Oh. Whoops. Alright, validate. What happened? It moved over because I accidentally placed something when I was just trying to move the trace there. Perfect. Save blueprint. And so this is just going to be a NAND with an inverter. So let's take our NAND. Now I want to move these traces. I think that's our input, so that should go there. And then I can move that to there. Or not. Oh. Looks like we only have one source of 0 and one source of 1. So let me move that. Bring that there. Validate. Now we're getting somewhere. Either or. Yeah, let's use the schematic. It would seem. There we go. Validate. Exclusive OR. So this is one input, but not both. So, I think I'm gonna get up to the adder, and then I'm gonna quit. So it has us building them from NANDs, but our problem here is that our NAND is huge. And as you can see, I'm not going for size at all. So I don't want to be here forever. Alright, let's validate that. And the music stopped and the game crashed. Oh, thank goodness. My progress saved, except it looks like... Oh, and my cat hit the lock button. Alright, that was my cat. The crash was not my cat. The thing that's missing is us to hit validate. I must admit, that is a satisfying animation right there. Okay, let's remove that and bypass that. That's my mistake. Repeated twice, it looks like. Alright, so let's validate again. That one's correct. Good. Good. And good. Alright, so now we've got a bit full adder, which is basically the building block of math in computers. Alright, that ended up being correct. Alright. Validate. I'm glad to see this one's moving faster. Oh man. I'm apparently on the really, really bad side of this. But I feel like it would take so long to compact these different devices. Like, I'm spending significant time on each one, and I'm just using the schematic and my blueprints. Yes, I know if I spent some time up in front working on compacting my original designs, then that would probably be better. And this one's just gonna be huge, because I need to put 4 of these. I can't even zoom out far enough. Okay, I think I'm gonna call it here. I don't want to wire this. Yes, I know it's just going to be some zigzagging, but I just don't want to. So at this point, it's important to remember that this game is still in development. I'm playing a pre-released version, and some of what you saw in this video may change before the full release. But with that out of the way, I wanted to discuss my experience for the game so that maybe it can be even better by the time you get to play it. Some of this may come down to my personal preference, but I did my best to put together some constructive feedback. First, the circuit designer mode controls were unintuitive for me. I cut it out of the video, but it took over 2 minutes for me to figure out how to build up and drag a trace over, then down again. The text instructions are good, but for me I accidentally clicked through them since I was trying to immediately click and move around and place things. I think there should be a button to replay the guides when you reset the board. Of course, maybe I missed it for that same reason, but it wasn't clear to me that I could move inputs and outputs, and why I could only move outputs to the edges, and exactly how to do that. Now, the smooth camera is nice and cinematic, but it's also a little slow and makes me feel like I don't have control. Additionally, Q and E on my keyboard were working, but my middle mouse click was not for rotating the camera. Next, it was hard to tell when I was in edit mode, and I couldn't figure out how to reliably get out of it. I kept trying to click on UI elements just to find that I had placed a trace somewhere behind it, or advanced the text instructions when I was just trying to click a button. UI buttons should take priority on top of every other click action. This next one would make a huge difference for me. Some sound or indication should happen whenever two traces connect, except for the one that you drag from. This could help indicate when you might have accidentally connected two sections you didn't mean to. Another way to show it might be quickly flashing a color from each newly placed trace that propagates a few traces away from itself, following any connected components or traces, so you can see easily what all is connected to the one you just placed. Second, about the lab. This is the room where you wake up in and that has all the consoles that you're trying to fix. To me, it wasn't very immersive. The room is a bit noisy design-wise. The glow of the text on the consoles makes it more difficult to read when you're not actually in the terminal. So potentially to improve immersion, maybe add some view bobbing for characters' steps and sound effects for those steps, then decrease how much the character slides around. I think it would also be helpful to add a field of view setting, as I feel like everyone has a preference, and I've even heard some people get headaches when they play at different FOVs in other games. And finally, maybe give the player a hand, or at least show fabricated components in the place of a hand when you're carrying them. Lastly, some general thoughts. I didn't feel like I was discovering things like I was in Turing Complete, because I was kind of hindered by the controls and felt like I wasn't getting real-time feedback on what I was doing and how it affected things. In Turing Complete, I feel like I was being taught how to build a computer, but in this game, I felt like I had been tasked with building a computer. It's hard to explain, but I feel like this could be a great learning tool with some more tweaks, if that's the goal, of course. Whatever the case, it's really cool to get to experiment with these components in 3D space, and it's definitely what makes this game unique. On the other hand, it's hard for me not to compare it with Turing Complete, since that's the only other game I know about in this genre, and I think the target audience might feel the same way. I can't wait to see how Hardchip continues to innovate and differentiate itself as it evolves in the future. So that's where I'm gonna call it quits. I made a single bit adder. The only other game of this nature that I've experienced with is Turing Complete, and that I spent hours and hours and hours developing my y86-64 computer. But in that, I just felt like there were a lot more creature comforts, like wires that can carry digital signals. Of course, you're building those up from the ground up, but once you build something, you then get to use it in a compact component. For this one, when you want to reuse a component, you're putting in the entire circuitry of wires. You're not just able to condense it into a series of inputs and outputs unless you do that manually yourself. I didn't put the effort, and then it came back to bite me later on. I know this could be better if I played it better, but I just didn't feel like I was in a good place to spend hours and hours and hours getting up to where I could have gone easily in a game like Turing Complete. Now, I also know that one of the main draws of this game would be its realism, how you will have to deal with 3D constraints like you would when designing a computer in real life. So there are pros and cons. There's an aspect of realism to this, but there's also how much realism do you really want in a game like this. So it's really up to the player to make of it what they will, and it's a very well designed game, works pretty well for what I can see, and it's still in development, so a lot of things could change before release. And if this game would be your style, or you want to follow it to see and check for updates, then I recommend you do so. I'll put some links in the description. And thank you so much to the creator, Etienne, for sending me this game and letting me try it out before release. Great work you're doing here. I can't wait to see where this game goes. If you made it this far in the video, thank you for watching. Please like, comment, and subscribe. Bye!